Okay, so welcome to a video on vectors. Now, a vector is a distance with a given direction. Okay, so what that means is it has what we'd call a magnitude, which means a size, so a length, and it is in a specific direction. Okay, so for example, you often see a triangle like this, and it might have 3 points on it, and we would say to get from O to A in that direction, it would be given to you as a vector. So in this case, that might be given to you as A. Okay, and then for example, I've drawn on this arrow going this way, so then if I wanted to go from O to B, I'd have to go in this direction, which is the opposite direction to this, so that would be negative B, okay, because it's going in the opposite direction to the arrow. So that means that if I was going from A to O, that's how we write it, we're going from A to O in that direction, then that would have a vector of minus A. And we underline these vectors. You'll notice I'm underlining all of these vectors, and that's how we always write a vector. If you're typing a vector, or if you see it typed in an exam, it will be in bold, okay? Whereas here, we can't write in bold, so we just underline it. So if I was going from B to O, I'm going in that direction, which is the same direction as the arrow, so it's positive, so that is vector B, okay? And the idea behind this is that you cannot go, if you cannot go from A to B directly this way, because there isn't a direction, there isn't an arrow, and there isn't a length on A to B. Okay, so think of it like roads. If you think about how you've got to get from Park House to Tesco, okay, you'd have to go down Andover Road to Budgeons or Co-op, and then along Monk's Lane. Okay, you could not go straight from Park House straight to Tesco's, because you'd have to go across all the fields, across all the houses, across the college to get there, and you can't bulldoze through all of that. Alright, so if for example we needed to get from A to B, so think of that as going from Park House to Tesco's roundabout, we'd have to come down Andover Road to get to the Budgeons roundabout, and then along Monk's Lane. Okay, so my direction would be, I'm going to go from A to O, so from Park House to the Budgeons roundabout, and then I'm going to go from the Budgeons roundabout to Tesco. Okay, so that's my route, the route I'm going. To get from A to O, I'm going in the opposite direction of the arrow, so that's minus A. And then to get from O to B, I'm going in the opposite direction to the arrow again, so that is minus B. So my vector A to B is minus A minus B. Okay, now if two vectors are parallel, that means they have the same direction. So they are the same vector, but they could be multiples of each other. So for example, if we had 2 points here, A and B, and we have this as the length A, if I have a parallel line which has exactly the same length, so it has the same length as AB, that would also have the same vector, an A. Okay? And if I had another line that was parallel but was twice the length, so E to F is twice the length, then that would have the same vector, but it would be twice the length, so it would be 2 lots of A. And that would mean all of these are parallel. Okay, so another way you can think about it is if you had a regular polygon, so let's say you had a regular octagon, I'm drawing here, might not look very regular, but it is. If this had a vector of A, then this would also have a vector of A, because it's parallel and it's the same length, because it's regular. If this had a vector of B, this would also have a vector of B, because it's parallel and the same length. If this had a vector of C, this would also have a vector of C going in the same direction. And if this had a vector of, let's call it D, this would have a vector of D in the same direction, because they're parallel and they have the same length. Okay, right, we're just going to do some exam questions now on this. So, these exam questions have been taken from GCSE exam papers. And the first question, we're writing the vector A to B. So we've got a regular hexagon, it tells us here, which means that if we draw any line in the same direction that's parallel to that, that will have a vector A. Okay, so we're going for A to B. To get from A to B, I can't go directly from A to B because I don't know what that vector is, so I'm going to have to go from A to O, and then from O to B. So A to O is going against the flow of the arrow, so that's minus A, and O to B is going in the same direction as the arrow, so it's minus A plus B. You can write it as B minus A, that means the same thing, but that's how you get from A to B, minus A plus B. Okay, the second part of the question says, the line AB is extended to the point K. So that AB to BK is in the ratio 1 to 2. So I'm going to extend this line and put on a point K here. And it tells us that A to B is 1 part and B to K is 2 parts. So in total, I've got 3 parts. This is a third and this is 2/3. Okay? And we've got to write down the vector C to K. So I'm going to do like I did before and work out what route I'm going to take. So I'm going to go from C to B, and then I'm going to go from B to K. Okay? Now, C to B isn't on there. However, because this is a regular hexagon, that means all these lengths are the same length. So that must mean that this vector is exactly the same as O to A. C to B is the same as O to A because they're parallel and they have the same length. So that must be A. So C to B is A, and then B to K is worth 2/3 and A to B is worth 1/3. So that means that B to K is 2 lots of A to B. Now I've already worked out what A to B is. A to B is this. So I've got to do 2 lots of A to B. Okay, so I'm doing 2 lots of that. So I get A, I'm just going to expand that bracket like you would normally. And so when I add those together and simplify it, you get minus A plus 2B. And that must be the vector C to K. Right, let's do a second exam question. Okay, here's my second exam question. I've got a triangle APB, and it tells me that N is the point on AP, such that A to N is 2B and A to P is just B. And we've got to write the vector P to B. So, to get from P to B, I cannot go directly from P to B because I don't know what that vector is. So I'm going to need to go from P to A and then from A to B. So P to A is going in the different direction to the arrows. It's going that way, and I've got to go B and then 2B. So that's going to be in total minus 3B, and then A to B is just A. So my answer is going to be minus 3B plus A, or A minus 3B. Okay, the next one. B is the midpoint of AC. M is the midpoint of PB. Show that NMC is a straight line. Okay, to show something is a straight line, they have to be parallel and they have to share the same point. Okay, so what we're going to do is we're going to do the vector NM, and then we're going to do the vector MC, and M is going to be our common point. So to get from N to M, I'm going to go from N to A. Am I? No, I'm not. I'm going to go from N to P, and then I'm going to go from P to M. Okay, and then to get from M to C, I'm going to go from M to B, and then I'm going to go from B to C. I'm just going to stop this video, but you need to follow it on the next video. Bear with.